Today we are going to learn the meaning of the gravitational field at a point. We are going to derive the expression for gravitational field at a particular point within the gravitational field. Here I have taken a mass. Since the mass is bigger like Earth, the mass that can be taken as capital M. Around any mass, there is a space. Within the space, if any other masses are brought within this space, that mass, smaller masses, they will experience the gravitational force of this gigantic mass. So around any mass we can draw a space. Within the space, its gravitational force will be experienced by other masses. Such space is called, what is this? Gravitational field. Here, if you take any point here, the gravitational force is experienced by any other mass will be zero. Therefore, the gravitational field is absent here. There is no gravitational field of this mass. So, in this region alone, that gravitational field is existing. Here we are going to derive the expression for gravitational field. Now you have to choose another mass. Let us choose another mass. That mass could be taken as a very small mass. Since it is small mass, we can use the letter small m. In between these two, we can draw a line. Are you clear? In between this bigger mass and smaller mass, you have to imagine a small distance. That small distance can be taken as r. Are you clear? So two masses are there, that is capital M and small m. The small m, that mass, is kept within the gravitational field of this bigger mass. Now we are going to calculate the gravitational field at point P. Here at this position, particular position, we have to calculate the gravitational field intensity or gravitational field to be calculated at point P. How to calculate gravitational field? For that we need which formula? That Newton's law of gravitation is essential. So according to Newton, what we have learnt, according to Newton, the gravitational force between these two masses can be written as F is equal to, what is F? Gravitational force in between these two masses is equal to G m divided by r square. So this is the expression from which we are able to get the gravitational force in between these two masses. That bigger one also exerts the gravitational force on the smaller one, and the smaller one also exerts the gravitational force on the bigger one. Are you clear? Now this force, that is nothing but the force exerted by m on small m. So in that manner we have to take. Here we have to write one negative symbol also. Why negative symbol, negative sign? Because the smaller mass is attracted by the bigger mass. For that purpose alone we have introduced the negative symbol. So from this expression we are able to calculate the gravitational force experienced by small m. Are you clear? Gravitational force experienced by which one? The smaller mass. Are you clear? So this is the formula which is obtained from Newton's gravitational law. After that, how to calculate the gravitational field? As per the definition, what gravitational field definition says? Here, this mass applies force on this mass. So here, there at point P, the small mass value must be unity. Are you clear? So here we have to place the unit mass. Are you clear? So at point P, the value of m must be equal to, let us say, 1 kg. So how much amount of mass must be placed? Unit mass must be placed. So I have written two letters, F and m. So to define the gravitational field, is it clear? Which two are required? The force is required and the mass is required. So to calculate the gravitational field at point P, both F and M both must be taken. So as per the definition of gravitational field, here the gravitational field that can be represented by the letter E. So E is for which one? Gravitational field. So this is the notation to be used. Gravitational field at a point P to be calculated. To calculate the gravitational field at point P, how to write the formula? Force experienced by unit mass. At point P, which one is kept? Unit mass is kept. That unit mass, it experiences the gravitational force exerted by the bigger mass. So therefore, how to write this? Tell me. F. What is F? Force experienced by. Who is experiencing the force? That unit mass is placed at point P, no? That one experiencing the force. So while saying the definition of gravitational field at point P, how to say? Gravitational field at a point P is defined as force experienced by unit mass placed at that point P. So in that manner we have to define the definition. Force experienced by the unit mass, that is the formula. So the next step, already we have learnt and derived the expression of F from Newton's law of gravitation. So instead of F, we can write it as Gmm divided by R square can be written. Divided by M can be written. What is M? M is nothing but the mass which is kept at point P. This is also M. So this much amount of force is experienced by the unit mass. So here also we can write 1. Since the value of mass is unity, we can write 1. Instead of M also, we can write the value of M as 1. It can be taken as unity, 1 kg, 1 milligram, 1 centigram of any value. That should be value of 1. Now M can be cancelled. So finally, the formula for E that can be written as minus Gm divided by R square. So this is a formula. By using this expression, we are able to calculate the electric field intensity, gravitational field intensity at that point can be calculated. Again, I will repeat. What is E? E is nothing but gravitational field at point P can be calculated by using this expression. By knowing the mass of capital M, that is mass of the bigger mass, and gravitational constant, and the distance between the unit mass and bigger mass, by knowing the value of R, we are able to calculate the gravitational field at point P can be calculated. Very important formula. This negative sign, that indirectly it tells that the nature of the force is attractive in nature. That's why the negative symbol is introduced here. What is E? E is nothing but gravitational field. Okay. It can also be called as gravitational field intensity. And here the force is measured in terms of Newton and mass is measured in terms of kg. So Newton kg inverse is the unit of gravitational field. So this is a very fundamental formula that must be known. Without knowing this fundamental formula, we can't learn the remaining things. Again, I'll repeat. E is clear, is nothing but gravitational field at point P. This value E that can be calculated anywhere within the gravitational field. Gravitational field is the space. At anywhere else we can calculate the value of E. The E value is 0 here. Outside the space, the gravitational value is 0. If any unit mass is placed here or there or here, its influence is not, the gravitational force influence is not felt by the mass here. Therefore, the value of E is 0 here. That you should know. Understood?